You know, when you walk into your house on a freezing winter day and turn up the thermostat, there's this invisible expectation of magic.
Right, you just expect it to work.
Exactly. You press a button, and within minutes, warm air or radiant heat just appears. And it feels completely local, right? Like it's just you, your walls, and your own little closed, self-sufficient loop.
Yeah, it feels incredibly intimate. I mean, the warmth is right there in the room with you,
Yeah.
completely under your control, responding instantly to whatever you want.
Yeah. But historically, behind your drywall, behind that little plastic dial, there has been a sprawling, hidden industrial empire.
Oh, absolutely.
Thousands of miles of steel pipes, massive concrete cooling towers, underground rivers of boiling water stretching across entire cities. You might feel like you're in a self-sufficient loop, but you're actually tethered to this giant aging beast.
It is an entire subterranean world that completely operates out of sight. We take it for granted right up until that massive infrastructure starts to age, starts to leak, and fundamentally starts to fail us on a systemic level.
And that falling apart and what we are rapidly replacing it with is exactly what we're exploring in today's deep dive.
That's a huge shift.
It really is. We are looking at the fascinating world of urban engineering, specifically focusing on the massive transition from giant centralized heating grids to autonomous localized heating systems.
Right.
And our guide for this journey is a really comprehensive university methodological guide. It comes to us from the National University of Water and Environmental Engineering in Rivne, Ukraine.
Yeah, it's a phenomenal, rigorous source. It's effectively a 90-hour, 3-credit master's level engineering syllabus.
Wow.
Yeah, condensed into a series of highly detailed technical and economic lectures about how cities actually function.
And our mission today is to uncover how moving away from those giant centralized utility grids toward localized independent systems isn't just some dry engineering upgrade.
Begins.
It is actually a revolution in personal comfort, economics, and efficiency. Ditching a 90-hour engineering syllabus to extract the best parts is basically like finding a hidden treasure map for energy independence. We're going to skip the heavy homework and go straight to the aha moments.
And this shift matters regardless of where you live, because understanding this transition reveals how taking control of your own resources can slash utility bills.
Right.
And, why continuing to pay for the invisible systemic inefficiencies of aging public infrastructure is essentially just leaking your own value into the ground.
Exactly. So to really understand why these new autonomous systems are taking over, we have to look at the massive aging problem they're meant to solve.
Right. The root cause.
We have to look at the legacy of the centralized grid.
Yeah.
And the source material focuses on Ukraine, which is a perfect case study for
Well,
this.
it's absolutely perfect.
Because their heating season lasts about half the year, with significantly colder temperatures than much of Europe.
Yeah. When a city is dealing with a 6-month heating season in sub-zero temperatures, heating isn't just an amenity. It's not a luxury.
No.
It is critical survival infrastructure. And historically, central heating, meaning heat generated at large thermal power plants and district stations miles away from the consumer, supplied over 80% of the housing stock in Ukraine.
Over 80%. I mean, that is a monumental achievement of mid-century engineering. One giant fire heating a whole city.
It really is impressive.
But here is the stark reality presented in the data. That infrastructure is crumbling. The source notes that the equipment is more than 70% worn out.
Yeah, 7%.
And the inefficiencies are just staggering. Heat loss during transport from the plant to the home reaches 20%.
Which is wild, because the acceptable engineering norm should be a maximum of 5%.
Exactly. And furthermore, coolant water leaks hit 18 to 20%, when the norm there is just 0.5%.
Those numbers represent a catastrophic failure from an engineering perspective. I mean, losing 20% on thermal energy, just pushing it through underground pipes, means the system is literally heating the dirt beneath the city streets instead of the actual homes.
Okay, let's unpack this. Imagine ordering a large pizza for your family.
Okay, I'm with you.
But the delivery driver eats 20% of it on the way to your house.
Not a great driver.
Right. And then drops another 20% right in your driveway. You are left with barely half a pizza, but you still have to pay full price.
That is painfully accurate.
That's exactly what's happening to the heat in these legacy systems. So I have to ask, is this just a failure of municipal maintenance, or is this massive loss a fundamental engineering flaw of building things too big?
What's fascinating here is that it stems from the physics of scale over time.
Okay.
When an entire city is wired into a centralized thermal network, You are dealing with hundreds, sometimes thousands of kilometers of steel piping.
Right, just a massive web.
Exactly. And over decades, constant thermal expansion from the boiling water, ground movement from freeze-thaw cycles, and general corrosion absolutely ravaged those pipes.
That makes sense.
But the real structural flaw is the cascading effect of those 18 to 20% water leaks. It's not just tap water leaking out.
Right, it's hot water.
It is heated, but more importantly, it is chemically treated water.
Yeah.
You cannot just pump raw river water or city tap water into a high-pressure heating grid.
Because of the minerals.
Exactly. The natural minerals, the calcium, would scale up and destroy the inside of the pipes and the boiler systems almost instantly. So the power plant has to spend a fortune de-aerating, softening, and chemically treating millions of gallons of water.
Oh, wow.
Yeah. And when 20% of that highly engineered water leaks out into the ground, the plant has to constantly draw in fresh, freezing raw water to replace it.
Which means they have to chemically treat that new water, heat it all the way up from near freezing, and then use massive industrial pumps to force it all the way back out across the city.
Exactly. The source explicitly highlights how this triggers a vicious cycle. This constant need to refill a leaky network massively drives up the cost of chemical water treatment.
Right.
It also requires the electric pump to work overtime just to maintain basic system pressure, which, wears out the pumping equipment exponentially faster. The entire centralized system transforms into a giant energy and financial sinkhole.
So the city is caught in a trap where fixing the pipes requires digging up hundreds of miles of streets, but ignoring them bleeds the budget dry.
Precisely.
It's no wonder citizens and builders are aggressively cutting the cord, which brings us to the alternative, right? Autonomous heat supply.
Yes.
The guide defines this very clearly. It is a system consisting directly of a heat source and the consumer. It handles heating, hot water, and ventilation with absolutely zero external thermal networks.
You are completely disconnected from the city's pipes.
Right. The heat is generated exactly where it is consumed. And the guide outlines options ranging from a roof-mounted boiler room for an entire apartment building down to individual double-circuit boilers inside a single apartment.
Yeah, let's actually talk about that for a second.
Yeah, let's clarify that term quickly. A double-circuit boiler.
It simply means the local machine handles two entirely separate jobs. Circuit 1 is a closed loop of water that travels through your radiators to heat the actual rooms.
Okay.
Circuit 2 is an open loop that takes cold water from the city main, heats it on demand, and sends it out of your shower head or kitchen sink.
Oh, okay. That's really efficient.
Right. And visually, the source material also highlights modern, multi-source inputs. We are talking about seamlessly integrating solar panels and ground heat pumps directly into these autonomous dual-purpose setups.
And the demographic shift reacting to this tech is wild. The statistics in the text show that the share of the urban population receiving central heating dropped from 55% in 1995 down to 45% in 2018.
That's a huge drop.
Over a decade, the total length of the central grid actually shrank from over 20,000 kilometers down to around 19,100 kilometers. People are actively dismantling the behemoth.
They are pulling the plug on a massive scale.
So what does this all mean? If we are abandoning the massive industrial power plant outside of town, and we are giving every single apartment building, or even every individual apartment, its own gas boiler, aren't we just moving the fire hazard and the exhaust pollution straight into people's living rooms?
Wow.
I mean, that sounds like a massive step backward for urban safety and air quality.
If we connect this to the bigger picture, the engineering of the units themselves evolved to solve that exact safety hazard. You're likely picturing older atmospheric burners.
Yeah, the ones with the open flames.
Exactly. Those older units pulled oxygen directly from the room they were sitting in to feed the flame, which could drastically affect indoor air quality and pose severe carbon monoxide risks if a room wasn't perfectly ventilated.
Right, the kind where you had to leave a vent open or you get a headache.
Right. But the source specifically details that modern autonomous generators use a closed combustion chamber.
Closed combustion, meaning it doesn't breathe the air in your living room at all?
Right. A closed combustion chamber draws its combustion air directly from the outside via a dedicated pipe, usually a coaxial chimney, which is basically a pipe within a pipe.
Oh, clever.
Yeah, it pulls fresh air in through the outer ring and pushes the exhaust gases right back outside through the inner tube. It completely seals the combustion process off from the interior of the home.
Wow.
So unlike old atmospheric burners, These modern units do not affect the room's air exchange or ventilation whatsoever. It ensures perfect indoor safety, allowing an industrial heating process to sit safely inside a kitchen cabinet.
That is brilliant engineering.
Right.
You get the power plant in your closet, but it's breathing through a snorkel out the window.
That's a great way to put it, yeah.
It doesn't touch your indoor air. But incredible snorkel engineering alone doesn't cause a massive demographic shift where 10% of a country's urban population cuts the cord in a single decade.
No, it doesn't.
There has to be a massive financial incentive driving this transition.
And the economic numbers in the source explain the rush perfectly. When you cut out the middleman, the 20% transport losses, the massive electricity draw for citywide pumping, the bureaucratic overhead of a district heating plant, the cost of supplied heat energy drops by 2 to 4 times.
Wait, 2 to 4 times cheaper?
Yes.
That is a life-changing reduction in utility bills for a household.
It is a massive margin. Users see up to 30% savings in their annual fuel consumption alone.
Incredible.
Plus, they save on the municipal electricity surcharges that were previously needed to pump that water across 10 miles of town. Because of this, the payback period for installing an autonomous system is 3 to 5 times shorter than the cost of a building hooking up to the central district heating grid.
I want to look at this from the builder's perspective first, because the guide points out something really interesting about real estate development.
Yeah.
If a developer is putting up a new neighborhood, connecting to the old central grid requires massive, unrecoverable upfront capital investments.
Well, yeah.
You have to dig enormous trenches, lay miles of heavy insulated pipe, upgrade city substations, and wait for endless municipal approvals just to get the hot water flowing.
Which can delay a project by months or even years. But with autonomous systems, builders avoid all of that heavy infrastructure. They simply build the house, mount the closed combustion unit on the wall, and the cost is rolled directly into the housing price.
That's so much simpler.
It drastically speeds up their capital turnover.
Yeah.
They can build faster, sell faster, and move on without being held hostage by the city's aging infrastructure timeline.
And for the consumer, the person actually living there, it changes the entire relationship with the home's energy.
Absolutely.
The source points out that individual regulation means you only use what you need. You slash gas consumption by more than half, and you completely eliminate reliance on state subsidies. Here's where it gets really interesting.
Yeah.
It's exactly like cutting the cord on a massive, expensive cable TV package.
Oh, that's a good analogy.
Right.
And taking that further, in a centralized system, there is a perverse incentive at play regarding conservation.
Right. Because for decades, we paid these massive cable companies for 500 channels, 490 of which we never watched. We were subsidizing the infrastructure of the whole giant network.
Exactly.
Going autonomous with your heat is like canceling cable and just paying for the exact streaming service you actually use. You heat one room to 70 degrees, you pay for exactly that heat, and not a single penny goes to heating the dirt under Main Street.
But giving the user absolute local control, their direct actions yield immediate financial rewards. If you feel warm and turn down your autonomous thermostat, your gas meter physically slows down. You save money instantly.
Yeah.
But in a centralized system, if your apartment is boiling hot because the central plant is overfiring for the coldest building on the block, what do? You open a window.
Which is madness when it's sub-zero outside.
It is. But it's the only local control you have. You cool down the room, but you are literally venting the city's money and fuel directly into the winter sky. There is zero incentive for conservation when the user is completely disconnected from the energy generation.
Opening a window in winter because the central plant is blasting too much heat really is the ultimate symbol of a broken system.
It really is.
But of course, nothing in engineering is a magic bullet. You can't cheat physics and you can't cheat scale. If the economics are a home run, the tech is totally safe, and it saves all this fuel, why hasn't centralized heating dropped to absolute zero?
Right.
Why is it still holding on at 45%?
Because autonomous systems have strict engineering disadvantages that the university guide is very clear about. And the biggest one involves a concept called installed capacity and the diversity factor.
Hold on, let me try to puzzle this out.
Sure.
If every single apartment in a city now has its own individual boiler, and each boiler has to be big enough to handle the absolute coldest, most miserable night of the year while someone is taking a hot shower, aren't we just creating a massive amount of wasted machine capacity? From a global engineering perspective, isn't sharing one big boiler actually smarter than building a million tiny ones?
This raises an important question. And it is the ultimate trade-off of autonomy. A centralized grid relies on statistical probability, which is the diversity factor.
Okay.
Engineers know that 1,000 departments will not all demand maximum heat and maximum hot water at the exact same millisecond. Some people are at work, some are asleep, some just like it cooler.
So the central plant doesn't need to be sized to 100% of the theoretical maximum load of the entire city.
Precisely. It can be sized significantly smaller, taking advantage of those diverse usage times. But an individual autonomous system does not have the luxury of statistical averages.
Oh, because it's just you.
Exactly.
Yeah.
It has to be perfectly sized for the absolute peak demand of that one specific user. So globally, across an entire city, you end up manufacturing, shipping, and installing a massive increase in the total capacity of boiler equipment compared to what is strictly necessary.
Ah, I see. You are trading transmission efficiency for hardware efficiency. We are basically over-manufacturing tons of metal and internal components that will just sit completely idle 90% of the time, just waiting for that one freezing Tuesday in February.
Exactly. You sacrifice peak global efficiency, the shared resources, in exchange for absolute local control, the speed of construction, and the total elimination of those 20% transport losses.
It's a heavy trade-off.
It is. Furthermore, the text outlines that autonomous systems have physical limitations regarding hot water supply. If you've ever lived with a small individual combi boiler and someone turns on the kitchen sink while you are in the shower, you've definitely experienced this limitation firsthand.
Right, the shower pressure suddenly drops or the water gets freezing cold.
Yes.
Why exactly does that happen if the machine is supposed to be so advanced?
Because a small combi boiler doesn't have a giant 50-gallon tank of preheated water sitting around. It has to heat the cold city water instantaneously as it flies through the pipes. To ensure the water actually gets hot enough for your shower, the machine physically restricts the flow rate. It slows the water down so it spends enough time over the burner. If you open a kitchen tap at the same time, the system simply cannot heat that doubled volume of water that fast. It hits a hard physical limit.
So it forces you to compromise locally. You can't run the dishwasher and take a shower at the same time without the system struggling.
Which is exactly why the text explicitly states that autonomous heating is not meant to completely eradicate central heating, particularly in areas served by highly efficient combined heat and power plants, or CHPs.
CHPs, those are the plants that generate electricity for the grid and then capture the massive amount of waste heat from that process to heat the city's water, right?
Yes, exactly. When a centralized plant is capturing waste heat that would otherwise just vent out of a smokestack, it operates at an incredible level of efficiency that an individual wall boiler can never match.
Makes sense.
In those specific zones, central heating makes perfect sense. Instead of a total replacement, autonomous systems occupy a specific niche. They complement the grid. They are deployed to create more comfortable conditions for specific consumers and to solve problems for developers in areas where the central grid is completely broken or just doesn't reach.
It's an ecosystem. The giant beasts of the central plants still roam the earth where they're efficient, but these agile, autonomous systems are rapidly taking over the niches where the giants are just too old, too leaky, or too slow to operate effectively anymore.
And understanding where each system thrives is the core of modern urban engineering.
Well, we've covered some serious ground today. Let's recap the journey.
Let's do it.
We started our deep dive looking at a towering, centralized behemoth of a heating grid in Ukraine, a system that was literally leaking 20% of its thermal energy into the dirt and bleeding almost 20% of its chemically treated water, forcing pumps to work overtime and driving up costs in a massive, vicious cycle.
A cycle that eventually forces the hands of both developers and citizens.
Exactly. Then we explored the solution, cutting the cord entirely. By moving to autonomous localized systems equipped with safe, closed combustion snorkels, builders can develop new housing faster without waiting for city pipes.
Right.
And consumers get a system that offers a 3 to 5 times faster payback period, massive fuel savings, and total personal control over their own comfort.
Even while acknowledging the mathematical reality that it requires a massive global over-installation of boiler capacity just sitting idle in our closets, it is a calculated, highly effective trade-off rather than a flawless utopia.
It really makes you appreciate the invisible physics happening behind your wall the next time you adjust the thermostat.
Yeah.
I will definitely be thinking about that 90-hour engineering syllabus from Rivne.
And I think there's a broader lesson here that extends far beyond urban heating grids.
Oh.
Yeah. If society can successfully decentralize something as massive, entrenched, and industrial as a city's thermal infrastructure just to gain personal efficiency and control, look around your own life. What other massive centralized systems, whether it's your technology platforms, your data storage, or even your personal finances, are quietly leaking 20% of their value into the ground, just waiting for you to pull the plug and go autonomous?